How to measure the inside diameter of your launcher barrel by Glenn Conti at Less Lethal Ballistics. Okay, so I got asked, what is the diameter of my launcher barrel? This video is going to tell you how to measure the diameter of your launcher barrel, or basically how to measure the diameter of any tube. Okay, this is a Berna LE, and here's the barrel. Now, this I'm going to use various pieces of hardware to measure the diameter of this barrel. This is the cheapest hardware. This is the most expensive hardware. What you should do is use the tools you have, or possibly purchase tools if you need to know with greater precision exactly what your barrel diameter is. Okay, so the cheapest method is to just get a scale. Okay, so here we have a scale that's going to allow us to directly measure the diameter of the barrel. What I would do is use the millimeters section of your scale, not the fractional, not the inches, because this is a decimal system and you can easier approximate what the barrel diameter is, and then you can convert that to inches. So what I would do is take the scale and find the widest diameter. Take a narrow diameter, fix one point, let's say on the left of the barrel in the inside diameter, and start rotating the scale until the numbers you're seeing in your head stop increasing and start decreasing, and then you stop, and that would be the measurement for your barrel. So using this metal scale, I have a reading of 17.5 millimeters. So that's gonna convert that to inches, and that is going to be your diameter measurement. About 0.689, something like that, is what it comes up to. So you're gonna divide by divide the millimeters measurement by 13.2, and I'm sorry. Divide by 23.2 and determine, I forget what the conversion factor is. I usually use a calculator to do it. But so you divide your millimeter measurement by the conversion factor, and that's going to give you your diameter in inches. Now, if you have a divider, this is a divider, you can get an even more accurate measurement. What you do is put the point on slightly into the inside diameter and expand the divider, rotate it and expand the divider till it will no longer increases. Now, so I'm reading the diameter using the divider, and then I'm going to place it. On the scale. Now, this is coming up with a value of about 17.3. So I'm interpolating between the two different hash marks on the ruler with greater accuracy. So before I could get it to 17.5 by doing a direct measurement, but with the divider, I can get it to more precise. Now, you can get dividers that are spring-loaded and have a threaded locking mechanism. So those dividers are only slightly more expensive than these dividers, and they will give you more repeatability in your measurements. Okay, so we were at, with this alone, we were at 17.5. With this, we got the 17.3. That's giving us a more precise measurement. If you have, these are inexpensive tools. So we were able to get to 17.3. All right, this is a more expensive tool. It's a digital caliper. It's made all of steel. Some of these are plastic, and they're less than $20. You're probably not, this method is just as good as using a plastic caliper, frankly. But this caliper is maybe a $30 or $40 digital caliper. So as you move this, it will change the measurement. So what you can do is you can go here and then rotate it. Okay, and this is giving me a measurement of 0.686 as far as the diameter of the Berna LE. Now, this, I don't know if I mentioned this yet, but this is like a $40 tool. You want to make sure that when you go to zero, it's properly zeroed. And then what you can do is, now we're starting to get in the realm of software. Okay, this is hardware to take a measurement, but you can improve your accuracy using software. What software? For example, you can use statistical methods. Instead of just taking one measurement, you can take 3, 4, 5. I would recommend, if it's really important to you, to take 10 measurements. Take 10 measurements of the barrel. Record each. So if for example, you got 16.85, then zero it. 16.85, there we go, that's 2. Rotate the barrel, taking it at slightly different places. 0.69, 0.6905, okay? So you would take 10 measurements, and the software portion is using statistics. Statistics is a mental method of improving the accuracy of your measurements. So if you took 10 measurements and you calculated the average, that's going to give you a better, more precise determination of what your true barrel diameter is. Now, to really get into the weeds, what you can do is then calculate the coefficient of variation over the 10 measurements, which is the standard deviation divided by the mean. And if the coefficient of variation is high, greater than 25%, 20, 25, 30%, then what you can do is not use the average. You can trim the most outlying top and bottom measurement, get rid of those, and then you would only have 8 measurements, which is a smaller sample size. But then what you could do is you can use a technique called Windsoring, where what you do is you take the second lowest and the eighth highest, and you duplicate those. So you still have 10 measurements, but you've gotten rid of the 10 outliers. So that's a statistical technique you can do to improve your measurement if your tools, your hardware, is not as precise as you want it to be. But for a $40 tool, we're getting pretty close. We're using the $40 tool, and we're using hardware, and then we're using software, statistics, with a calculator to improve the measurement even better. Now we're getting into the realm of more expensive measurement devices. These measurement devices usually come with calibration certificates, inspection certificates, to tell you whether or not these devices have passed a quality control inspection for their repeatability and their ability to measure. Now, so this is a Mitutoyo caliper. It's a vernier caliper. It's not digital. It's around $100. Their digital calipers are about $150. The only problem with their digital calipers is they're counterfeited in China. And you can find, they're supposed to be around $150 to get the real Mitutoyo caliper. But you can, if you buy a digital one, that's much easier to counterfeit than these vernier type with the dial. So that's why I have this. It was about $110, but now I can do the same thing. But so these have very high repeatability. Now this is saying, let's see here. Want it zeroed, it's right on 0. Come out. Now this is giving me 0.6892. So this is giving, and now I could do the same thing where I take repeat measurements. This is, and then rotating it, because the barrel is going to have a plus or minus tolerance, manufacturing tolerance. Typically these things on a good manufactured barrel is going to have 2 10,000ths of an inch tolerance, plus or minus 2 10,000ths. But it might be more on a more variance, manufacturing variance on a lower cost launcher. Now, there's an inherent problem with using these calipers, and that is these calipers can have, instead of a blade, they can have a flat. So if you're using a caliper that has a flat, what you can do is do a technique similar to what we did with the divider and the ruler. You can get one of these devices. It's called a telescoping gauge. So what you do is, just like the divider, you can read the inside diameter. So what this does is you loosen it at the bottom, and these are springy. So what you can do is you can insert it. Now these come in various sizes, so you would need to get one that lives in the range of about 1/2 inch to 3/4 inch. Because you can, depending on the diameter hole, but we're just talking about barrels on launchers. So if it's a 0.68 caliber, you can be 0.5 to 0.75 all day long. and you only need one of these. So what you could do is you insert it, and you want to make sure that the telescoping gauge is parallel to the length of the barrel. And now you lock it and pull it out. Now, so this distance, it's got a rounded edge, and this has got a rounded precision metal edge. This device is about $40 from Mitutoyo. And it is, so what you could do is you could take it and you can measure it. Now this is saying 0.6925, okay? So we're getting closer and closer. Or you could use your more expensive caliper, same thing. Okay, 6.9. This is saying 6.9175. So use a telescoping gauge for around $40. Read the measurement of the diameter, lock it, then put it to your hardware to read the diameter off of the telescoping gauge. Very similar to what we did. We read the diameter with the divider and then applied it to the measurement device. So it's a very similar technique. Now, if you need greater precision than just 3 to 4 decimal places, what you can do is you can go from a caliper to a micrometer. So what we could do, let me turn this on, okay. Now you would zero this, and then make sure you would set it all the way back and zero it, and then take your measurement here. Okay, so I'm just going to skip that step for brevity. But so here it is here. Now this is a ratcheting tuning device. Well, I didn't lock it in tight enough. So let me just take another measurement here. I'm going to lock it in tightly. And then what I'm going to do is measure with the micrometer. Okay, I'm going to set units to inches. Okay, this is saying 0.69000. So you see how my precision has increased with the micrometer. This is a low cost micrometer. It's probably a $40 micrometer, so it gives me more precision, but it might not be as accurate, even though it's giving me many more decimals of precision. It's out 1, 2, 3, 4, 5 decimals of precision, but because it's lower cost, it might not be as accurate. So then you would use, if you have a lower cost tool and it's not giving you repeatability, then you would use the software techniques, which is statistics, calculate the average, the coefficient of variation, Windsoring to trim the outlier measurements. Now, Of course, we're in the weeds now, and we're totally in the rabbit hole. But what you can do is you can get a gauge block to calibrate your devices, your measurement devices. What this is, and this is about $40. No, this is about $30, $25. It is a block that is very, very precisely made to be, let's see here, to be 5 millimeters. So I'm gonna set this units to millimeters, and then we're gonna, so you can calibrate your tools using a gauge block. And this is, I think it's like, this is a class 0 gauge block. All right. Class 0 means it's been made to be very precisely okay. I'm gonna okay, we're going. Okay, so now this is the gauge block. Now this device, which is only let's say a $30, $40 micrometer, is reading 5.001 on the gauge block. So this is not a bad device as far as being able to read. And you could even zero it here. No, you can't zero it because you're at 5. But this gauge block is giving me an indication of how well this measuring hardware is going to do at giving me a measurement. Now you want to again have high repeatability. If you don't have high repeatability, then you use statistics. All right, so that's that. That's that. So we got the telescoping gauge, we've got the gauge block, we've got the micrometer. Now, if you totally want to go into the weeds, this is a Mitutoyo 3-point hole gauge. These puppies go for around $1,300 a piece. And they only measure within a small, narrow range. This one measures from 0.65 inches to 0.8 inches only. But because I live in 68 caliber, it was beneficial to be able to buy one of these so I can get a very precise, repeatable measurement of barrel diameter. Of course, you're not going to want to do this. Now, what you would do is you would use this calibration disc that comes with it, insert the bore caliper into it, and then you would zero the device. So I'm not going to do that for brevity because no one's going to spend $1,300 for a tool except for someone insane like me. Okay, so what you would do is insert it in. And take your measurement. This, I haven't recently calibrated this, so it's not giving me a good measurement. But you can see there are 3 points that it's measuring instead of just 2, like the telescoping gauge or the divider. So it's expanding, and it's going to measure the diameter to 1, 2, 3, 4 decimal places, and it's going to do it with precision. So there you have it. These are the various pieces of hardware you can use to measure the diameter depending on what your needs are. And I did want to talk 1 second about brands. The Japanese brand that also makes stuff here in America is the Mitutoyo. That is a very respected brand. The American brand that's very respected is Starrett. Now, what we're doing is we're trying to use science to solve our problem of being able to take an accurate measurement of some physical thing, characteristic in the real world. Now, science, you would think, is all fact-based and et cetera, et cetera. But if you are going to purchase your tools based on the brand name, you're not talking about science, you're talking about faith. You have faith in the brand name, and you're going to use that faith to solve a problem. So a lot of times science is based on assumptions. At the very base level, you've got an assumption, and that you're going to take on faith, and then you're going to use common sense and deductive and inductive techniques to build on those common sense assumptions to build a whole house of cards, and that's science. So we've run the gamut. We've talked about hardware, we've talked about statistics, software, and now we're talking about the philosophy of science, which, as it turns out, is based on assumptions, and you have to take those assumptions on faith. So this video, by the way, can be used for any inside diameter measurement that's smooth bore on any tube. So it doesn't just have to be barrels. It has a wider application. I wanted to thank my father, who was a machinist, who taught me. I wanted to thank Virginia Tech, who was in their engineering program, and they taught me a lot, and especially the statistics portion, the software portion of being able how to improve your accuracy of what your hardware says by using statistical techniques. That was Virginia Tech. Then I wanted to thank Charlie Ware, who exposed me at Maritime Tool, who exposed me to this device, and the technique of using a separate device to indirectly come with a higher precise measurement than you would have if you had just measured the device directly. So that's using the divider with the scale, or using the telescoping gauge with either the caliper or the micrometer. And then finally, I wanted to thank Dan Sterling at Sterling Self-Defense. He exposed me to the 3-hole bore micrometer. This is the most expensive piece of equipment, and that will give you the best reading. But by the way, these can be bought used, if you're lucky, for the $400 range. But list price on this is $1,300. But that's it. Thank you for taking the time to watch this, and I hope you have happy trails.